Good morning, students. Today we are going to introduce an important concept from metallurgy, that is extraction of crude metal from concentrated ore. Extraction of crude metal depends on nature of ore and impurities. So, extraction of crude metal depend on nature of ore and type of impurities. In this process, two steps are involved. That is conversion of concentrated ore to its oxide form. This is the first step. Step 2. Conversion of oxide ore or oxide form to crude metal. These are the steps involved. Now first one, let me discuss conversion of concentrated ore to oxide form. So we have to convert concentrated ore to oxide form. That is, in this method, oxidation takes place. What is the method we have here? Oxidation. Conversion of concentrated ore to its oxide form can be done by oxidation. Here, two methods are involved. One is calcination and the next one is roasting. Calcination and roasting. What is meant by calcination? Look here, calcination. Calcination nothing but heating the ore in absence of air. Heating the ore in the absence of air. This is we are calling calcination. So here what we are doing means concentrated ore going to be heated in the absence of air. For example, zinc carbonate is subjected to heat in the absence of air. We are getting zinc oxide and carbon dioxide. This is zinc oxide. Similarly, Fe2O3 X water molecule are subjected to heat. Hydrated ferric oxide. Then it will give ferric oxide and water, X moles of water. This is ferric oxide. And you take dolomite, CaCO3, MgCO3. This is we are calling dolomite. It is subjected to heat. Then we are getting calcium oxide, magnesium oxide and carbon dioxide. Like this, in the absence of air, we are heating the concentrated ore. Then you are getting respective oxides. So this is the steps here we have. Conversion of concentrated ore to its oxide form. So zinc carbonate converted to zinc oxide, hydrated ferric oxide converted to ferric oxide, and dolomite carbonate form converted into oxide form. So we got oxide form. During this method, what the changes will take place means changes are takes place, that is volatile impurities are escaped. Volatile impurities are escaped. Then water is removed. Water is removed from hydrated salts. Hydrated salts. That is hydrated ores. Carbonates converted to oxides. If any moisture is there, that moisture also removed. These are the changes takes place during calcination. Volatile impurities are escaped, water removed from hydrated ores, carbonates converted to oxides, and if any moisture is there in the ore, that also will be removed. These are the changes. The next one we have roasting. Let me go for about roasting. What is meant by roasting? What is meant by roasting? Look here, we completed calcination. Calcination nothing but heating the ore in the absence of air and removal of impurities, and concentrated ore is converted into oxide form. Next, roasting. What is meant by roasting? Roasting also is a heating process like calcination, but small difference is there. Heating the ore strongly. Heating the ore strongly. Heating the ore strongly in the presence of air. In the presence of air. Calcination in the absence of air, roasting in the presence of air. That is, air should be excess at high temperature. At high temperature. Below the melting point of metal. So we have to heat strongly and at high temperature, but it should be below the melting point of metal. If we heat more and more above its melting point, metal will be melted. That's the problem. Then, in this process, what the changes takes place? Generally, this process for sulfide ore converting into oxides. Remember, this is very important point. This roasting process is only for to convert sulfide ore to oxide ore, not for all. And the impurities are removed, such as sulfur, arsenic, phosphorus in the form of their oxides. Sulfur in the form of sulfur dioxide, arsenic in the form of arsenic trioxide, phosphorus in the form of phosphorus pentoxide. Like this, these are removed. If moisture is there, that moisture also removed. Let me go for what the changes. For example, where I told already sulfide ores are subjected to convert into oxide. I am taking zinc sulfide. It is strongly heated. Heating means in the presence of air, I told, that's why oxygen is added. Then zinc sulfide converted to zinc oxide plus sulfur dioxide is evolved. Sulfur dioxide is evolved. And similarly, lead sulfide. I am taking lead sulfide also. PBS. This is we are calling galena. In the presence of oxygen, gives lead oxide and sulfur dioxide. Lead sulfide galena, zinc sulfide, zinc glands also we are calling zinc glands. Like this, they form oxides. Similarly, I am taking one more oxide, that is copper oxide, copper sulfide. This copper sulfide subjected to heat in the presence of oxygen gives copper oxide plus sulfur dioxide. Copper oxide plus sulfur dioxide. You know very well, this is we have called as ruby copper. Remember this. Which copper ore is known as ruby copper, means Cu2. Like this, in roasting, sulfide ores are converting into oxide ores. Now, during conversion of these sulfide ores to oxide ores, this total process takes place in reverberatory furnace. Total roasting process taking place in reverberatory furnace, where roasting takes place in reverberatory furnace of copper sulfide. If this copper sulfide contains impurities such as iron. If copper sulfide consists impurities such as iron, immediately silicon dioxide is added before heating. So where you are doing roasting process of copper sulfide, if it is contains iron impurities, before heating only silica is going to be added. What happened means this iron silica react with this copper sulfide form iron silicates. So iron form iron oxide and it react with silicon dioxide and form iron silicates. And this iron silicate in the form of slag. Slag nothing but easily fusible substance. But this iron silicate is formed in the form of copper sulfide plus a little bit iron sulfide. So slag is formed in the form of the mixture of copper sulfide and iron sulfide. The mixture of copper sulfide and iron sulfide, well known as copper matte. Very important for exams. What is the composition of copper matte? Cu2s plus Fes, copper sulfide and iron sulfide. It is more in percentage, it is less in percentage. The mixture of the composition of copper sulfide and iron sulfide is known as copper matte. Like this, calcination and roasting will be takes place. Next, the second process, second step we have conversion of oxide to crude metal. Conversion of oxide to crude metal. Conversion of oxide from crude metal. In this process carried out in the presence of reducing agents means it is a reduction process. It is, I told already, oxidation process. Conversion of concentrated ore to oxide form is oxidation. Conversion of oxide form to crude metal is a reduction. That's why here we are using reducing agents. What reducing agents we are using here means coke, carbon monoxide or any other metal. Any other metals we are using. So here where we are using reducing agents,